Hey folks, Doug Henshin, VP and Principal Analyst at Constellation Research, here to talk about analytical data platforms. What am I talking about? Well, analytical data platforms would include data warehouse platforms, data lake platforms, and increasingly what we're talking about is combined lakehouse platforms. So let's dive in. So high-scale analytical data platforms have been around for decades now, but they've steadily evolved. Where once we talked about relational database management systems deployed on premises to create data marts and data warehouses, today most of the growth is in cloud-based platforms that are delivered as a service. And what's more, the nature of the platforms has changed. So today most of these analytical systems have an underlying storage layer or closely associated data lake that's built on low-cost object storage, such as Amazon S3, but every major hyperscaler has their own object storage option. And once again, this layer is typically, obviously, in the cloud. So a modern lakehouse platform then combines this high-scale data lake with the data processing options, such as Apache Spark, and a performance-oriented SQL engine. In some cases, they have multiple SQL engines, and thus the platform can address the data engineering, AI, ML, increasingly Gen AI, which I'll lump together as data science, and then SQL-centric analytics, for BI and reporting and dashboarding and all that sort of thing. So I talked about some of the long-term trends, but let's put them in context. From 2015 to 2020, we saw a massive move to the cloud. That trend continues. Architecturally, we saw the separation of compute and storage, which is what enables you to run multiple engines against that same data in that underlying platform without having to move or copy the data. We also saw a rise in interest in data science, specifically machine learning and AI back in that time frame today. That's moving into the Gen AI area. We're also now in the middle of this 2020 to 2025 period, where we've seen the emergence of blended lakehouse platforms. So now that object storage is in place as the primary storage layer, we've seen data science-oriented vendors like Databricks, for example, bolster their data warehousing. And conversely, we've seen the data warehousing-oriented vendors like Snowflake, for example, bolstering their data engineering and data science capabilities. Now, both camps are trying to say to their customers, our platform will let you do it all with your data. And that's very much what the customers want. But the progress towards this nirvana of being able to handle every kind of workload continues. So customers, meanwhile, have made it clear that they don't want their data locked into proprietary formats, and for that matter, they don't want them locked into a single cloud. So they have been increasingly insistent on open standards with three formats: Apache Iceberg, Delta Lake, and Apache Hudi, in that order of popularity, being the top choices. Now, with these table structures, what it's promoting is SQL performance for the analytical workloads. So most vendors now support one or more of these open standards. Now, looking ahead, we're already seeing interest in generative AI, and this is leading vendors to add features like vector embedding and vector search to their platforms, along with better support for the unstructured data. So, text, images, audio files, video files. A lot of focus really these days on the text and unlocking that with the natural language capabilities of large language models and Gen AI. So with that better support for unstructured data, you can get things like natural language query, SQL generation. Features are widely in preview now, and in a few cases, they're even generally available. But it will really be from 2025 to 2030 that we're likely to start seeing real productivity gains where Gen AI is concerned. And so some of the promises are that it will democratize these analytical data platforms, supporting querying for a broader base of users, helping to optimize the existing queries, helping to document and explain both existing queries and new queries, because documenting, understanding what goes on in a query, what it's looking for, is very important. And finally, Gen AI promises to open up more use cases, particularly those involving unstructured content that we really haven't been using very broadly, such as documents, email, CRM notes, audio files, video files, etc. So this will turn analytical data platforms, heretofore, which have been more focused on structured data analysis, columns and rows, into multimodal data intelligence platforms. So just to make it clear which vendors I'm talking about, the platforms associated with data warehousing today include the likes of Amazon Redshift, Google BigQuery, Oracle Autonomous Data Warehouse, Snowflake, and Teradata. Now, all of these vendors would be quick to tell you that they can support data engineering, data science, and AI workloads, as well as unstructured data. But today, that's not really their primary usage. That's capabilities they're adding and trying to accentuate and improve the adoption of those features, but it's not the raison d'etre, the primary use of these platforms. The second batch here, Cloudera and Databricks, really got their start supporting data engineering and data science, including AI and ML. And that was, back 10 or more years ago in the big data era. But they've added SQL-based data warehousing to effectively become lakehouse platforms. Now, Cloudera has a big presence on premises these days and is pushing into the cloud, while Databricks is entirely in the cloud on all three of the major hyperscalers. Now, finally, there's a third camp here of the data fabric or virtual lakehouse players, and this would include Denodo, Dremio, Microsoft Fabric, and Starburst. Now, this camp is all about accessing data where it lies without having to move it or use ETL or copying it. In the case of Denodo, Dremio, and Starburst, it's mostly about providing access and governance teamed with SQL analytics engines for distributed querying. And they also have caching layers to accelerate those mission-critical queries. Now, if you want to do data engineering and data science, that's not really what these platforms are about. They'll point you to, Spark or the third-party data science tools that your data science teams are likely already using. But that's not really what these, virtualized or federated data access platforms are about. Now, Microsoft does offer multiple engines, both data science and analytics, along with its very new Microsoft Fabric platform. But I'd caution that the Fabric is a very new offering at this point, and we're just starting to see customer adoption and proof points on that platform. As far as the what to look for is, if you're starting from scratch, most vendors now do address the need for both a data lake and a data warehousing capability, meaning they effectively offer what's colloquially known now as a lakehouse platform. But a few organizations ever start really from scratch, so it's not always a clean sheet. You always have you tend to have existing estimates that you have to look out for and consider. So if you're looking to fill gaps or to modernize, or is it going to be on the data engineering side? Is it the data science side? Is it the data warehousing side? And what are the vendor's strengths? And it tends to be that where companies came from, if they came out of the data warehousing world, that's probably going to be their strength. If they came up as a data science platform, that continues to be their strength, even if both sides are trying to bolster their capabilities in the area that they weren't really known for previously. This hasn't changed overnight, and those companies are still making progress into the area that they weren't formerly known for. So the hyperscale cloud vendors, meanwhile, particularly AWS and Google, really do address both the AI, ML, Gen AI side of things, and also the data warehousing analytics. But the question then is whether you have a multi-cloud or an on-premise requirement, which they don't address so well. In the case of Google, they do have BigQuery Omni, which lets you query against some of the other data in the other clouds, but it's not really a multi-cloud a system that you can deploy on multiple clouds. Now, no matter what you choose, I would make sure that the vendor supports industry standard data formats and table formats such as Parquet and Iceberg. If it's a proprietary database format in particular, That might restrict your flexibility down the road. It can introduce friction and cost if and when you decide that you need to make a change. Now, lastly, assuming that you're choosing a modern cloud platform, I would make sure you can tap into flexible, responsive serverless capacity, particularly if you expect to be doing spiky AI and ML workloads. What's more, make sure there are automation capabilities and or a clear roadmap for increased automation capabilities if they're not quite there yet. You want the administration and operations to be as automated as possible, of course, with some knobs and dials to customize where need be to ensure that you meet SLAs. So a modern cloud-based platform should be smart enough to automate much of the system admin and even the workload optimization. And if not, that should be on their roadmap. So take a close look at that. Now, finally, I mentioned shortlists, and I'd suggest that you look at our shortlists at constellationr.com/shortlist and check out the 2 relevant shortlists that I offer on analytical data platforms. I have one on automated cloud data warehouse services. Obviously, the emphasis is on data warehouse operation that is highly automated. And the second is on hybrid cloud and multi-cloud analytical data platforms. These are the products that address those on-prem and multi-cloud requirements. So with that, I thank you for watching. Look to constellationr.com/shortlist, and I wish you the best of success with your tech selection.